Okay, so here we have a hydraulic jump example problem, and we're ultimately trying to determine the discharge in this channel, and the channel cross section you can see right here. This is about as hard of a problem you can get in a hydraulic jump, just simply due to the extremely weird nature of this channel cross section. So first things first, when talking about hydraulic jumps in problems, we have to remember that M1 equals M2, and if you look on your equation sheet, it is given that M is equal to y bar times A plus Q squared over G times A, and that's for any point. So if we're looking at the M1, it would be M1, Y1, A1, and then A1 here as well. So that means that we're going to need to find y bar and A for both points 1 and 2 in order to solve this equation for Q2, or Q squared. So we'll start off with A1 because that's probably the easiest part. So A1 is simply the area of this zone right here, and that's just 2 times the width of this channel, which is given as 19. So we have 2 times 19, which is 38 feet squared. Then we have y bar 1, and that's simply the centroid, the distance to the centroid measured from the top, or from the water surface, and that in this case is just 1 feet, or 2 over 2. So we have that to be 1 feet, and then we can find y bar, or y bar 1 A1, which is just 38 times 1, so we have 38 feet cubed. Now, to move on to the second part, we have the area of point 2, or of section 2, and this is where it gets a little bit tricky. We're going to split this into 3 different sections. First, we have section A right here, and the area of section A is 5 times the width, which is 19. Then we have the section B here, and the area of that is 4 times 7 feet. And then we have the area of section C right here, which, since it's a triangle, we have 4 times 4 divided by 2. Now, in order to find the centroid of this thing, we have to multiply the centroid of each individual piece times the individual area of each piece. So, in order to do that, we have y bar A of section 2 is going to be, since this part right here is for part A, this part is for part B, and this part is for part C, we need to take the centroid from the top of this water here to the centroid of section A, which is in the middle here. So that's going to be 4, this distance here, plus half of 5. So we have 4 plus 5 over 2, and that's going to be all times this A portion right here. So we have 5 times 19. That's going to be plus the centroid of point B, which is just halfway down, so that's 4 over 2. Times, again, this portion for the area of point B, which is 4 times 7. And finally, we have the centroid of point C, which, since it's a triangle, the centroid is 2/3 down, so that's going to be 2/3 of 4, so 2 times 4 over 3, times the C portion here, which is 4 times 4 over 2, and we get a final value for y bar 2A2 to equal 695 feet cubed, and a value for A2, if you do all this math here, we get a value of 131 feet squared. Now we know all of the necessary pieces in order to plug them all into this equation here. So if we write that out, we would have y bar 1 A1 plus Q squared over G times A1 going to be equal to y bar 2 a2 plus q squared over g times a2. And we just plug these things in here. We get, actually, to make this more simple, instead of plugging all these numbers in, we're going to solve for q empirically before we do anything. I'm not going to go through how to do that because it's a pain, but when you do end up doing that, we have g times y bar 2 a2 minus y bar 1 a1 all over 1 over a2 minus 1 over a1 and all of that square root. And when we plug, we know what g is, we know what y bar 2 a2 is, we know what y bar 1 a1 is, we know what a2 is, we know what a1 is. So if we plug all those values in, we get a value for q to be 1064 CFS, and that is what the problem is asking for. Just make sure that you know how to use this equation here. You're not going to be asked to do anything this crazy, I would assume. Don't take my word for that, but yeah, hopefully this helps. This is a very, very complex example of a hydraulic jump, so good luck on your test tomorrow.